Okay, I see only one. That's our speaker who is an open source enthusiast and Google Summer of Code mentor, Shivay, an expert in DevOps, ML, and full stack developer. We'll talk about building machine learning, microservices, and MLOps using UnionML.
Thank you.
Take it away.
All right. So first of all, I'm super excited to be presenting here. It's my first PyData conference in person as a speaker. I've previously been also an organizer for PyData Delhi, so I'm part of the PyData Delhi group, and I've also given a few talks at PyData Global. So super excited for that. And unfortunately, my co-speaker Gaurav could not make it because he had to fly in to India due to an emergency. But both of us actually presented the same title of our talk as a poster presentation just last week at PyCon. So we'll be more than happy to share that as well. But yeah, without wasting any further time, let's get started. So I'm Shivay, I'm a developer relations engineer at Microservices, and I've previously been also, I've worked with Union AI, and a lot of my expertise and my experience has primarily been in the space of machine learning and DevOps, so contributing to projects like Kubeflow. And so if you want to connect with us, these are our Twitter handles. Of course, I mean, this is a PyData meetup and it's conference, and so a lot of you might be aware of what machine learning is. But just a quick show of hands, how many of you are aware of the machine learning lifecycle? Is everyone aware of the general machine learning lifecycle? And it appears to be quite a few of you. But I'll just quickly reiterate of what happens, right? We usually start with probably a data set that you can collect. Then of course, since that data set might be having of different resources, so you might have to clean it. Then you'll do a bit of feature engineering. Then you'll pass that particular data inside of a machine learning model to train that model, and it will help you to set the weights and biases for that particular data. And then once the model has been trained, you will go ahead and then predict and see whether the model actually makes correct predictions. And if it does, then you will go ahead and deploy that model. And if you look at this entire machine learning lifecycle, of course, the entire ML code that you'll write with it is a very small part of the entire machine learning system. So other things that come as part of the entire machine learning system include things like the setting up of the infrastructure that is required to actually run these models and train, predict. And then, of course, you have to continuously monitor your models once they go into production as well. And of course, like the data collection itself is a very major overhead for the data scientists, for machine learning engineers when they are dealing with the training of the models. And of course, one of the key things to always also keep in mind is that traditionally, if you look at the vision of data scientists or the way they kind of look at DevOps, right? So as a data scientist, their primary job is to collect the data and then ensure that the models that they train are fit well with the data. And when it comes to like probably asking them that, hey, would you like to probably also predict or probably just go ahead and productionize this model, so go ahead and work with things like DevOps, they try to shy away. And especially it also happens with DevOps engineers as well. If you ask them that, hey, would you want to probably work on a non-software engineering related workload that could be to deploy a machine learning model, they probably might shy away. And that's a common misconception that people have. So if you're doing some kind of a machine learning engineering, it's, I would say, very similar to a standard software development engineering as well. So the same set of tools that you typically use for a DevOps workflow for a software engineering project can be applied to a machine learning project as well. So what we say is that essentially MLOps is a subset of DevOps. So similarly, how dev or software development requires DevOps, you need machine learning MLOps for machine learning projects as well. And of course, the most important aspect of why you need MLOps is that the machine learning models have the tendency to deteriorate over time. And when you work with larger models, they can be very complex. They might require a lot of infrastructure as well. So for example, today we work with GPTs, so these are large language models. So you might not just be able to actually work only with one single GPU, you might need a multi-GPU strategy as well. And so with so many hardware requirements and with the tool set required to continuously monitor your model once it goes into production, MLOps is really the process of deploying and then also monitoring and maintaining your machine learning models in production once you have done your initial bit of research and trained your model locally as well. And if you look at the state of MLOps, it can be very confusing. So this has been borrowed from the LFANI, which is the Linux Foundation AI. And you can see that whether it's for model training, for cleaning your data, for production usage, and then monitoring your model in production, there are so many different tools today that exist inside the entire machine learning ecosystem that it can be confusing to use, to try to find, okay, which one should use. And especially as a data scientist, right, the major goal for a data scientist to ensure that they use the right set of data, and also then ensure that the model that they are fine-tuning is very well addressed to the data set that they are dealing with. So instead of them having to worry too much about which particular data to use, their major focus should be to ensure that the model that they train is working well. So the major goal for this talk and what we are trying to kind of overcome is that the data scientists should not worry what type of tools they're using, and especially if they are dealing with these tools, how can we lower that layer of abstraction or that boilerplate code that they might have to write when they have to deal with all these set of tools. And there are some other inherent problems that we also deal with MLOps. So of course, the biggest one I would say is that a lot of times when, as a data scientist or as a machine learning engineer, you're reiterating over a lot of the different code that you write in order to fine-tune your machine learning model, right? And this might probably require you to use some hacks. But of course, when you try to productionize your machine learning model, those will not work as well. So the need for being able to copy or essentially take that boilerplate code that you have written while you're doing your local testing, a lot of times you will have to rewrite that same code logic when you are writing your machine learning model in production and when you are essentially productionizing your machine learning model. And of course, then the other one is that there are so many different tools and so many different frameworks to choose from. So which one should you use? And in case you want to probably switch between these frameworks, you'll have to write a lot of boilerplate code again to fit your machine learning model data set. And then there might be a lot of lack of clarity when it comes to deploying your model. How do you actually do that? Can we probably replicate it across different types of data sets that you might have or you might be dealing with? So the major goal of today's talk is to essentially overcome some of these limitations that we see inside of MLOps. And another thing that we also want to focus on is to be able to create a standard and also unify the different set of toolings that is available for machine learning. So similar to how we have a lot of different web standards, we have standards for APIs, open API specs, can we also define certain set of standards for machine learning as well? So whether we are dealing with probably with datas or datasets, or we are dealing with machine learning, how can we unify and bring in standardization for both the machine learning models and also the data that we are dealing with, right? So that's the major goal. And that is how you're actually able to achieve that with the help of UnionML. So UnionML is an open source tool that has been built on top of Flight. So if you're not aware of Flight, there was in fact a tutorial for Flight yesterday by Eduardo from UnionAI. How many of you attended that tutorial? So I see a few hands. But yeah, I mean, it's a very well-known open source project, part of the LFANI. And so essentially the main goal of UnionML is to provide a unified experience that that you can actually use to very easily build and deploy machine learning based microservices. And we'll understand that how that kind of works and how UnionML actually works under the hood throughout the course of today's presentation. But the idea really simply is that you have a machine learning project. It could be a Jupyter notebook, but you can convert that with the help of a standard set of methods. Typically, these are decorative functions that are provided to you. And with the help of this single Python app, which we also call as a UnionML app, you can very easily deploy these across a broad spectrum of different ways. So whether it's just with the help of a fast API-based web service, or even deploying it on a Kubernetes native environment so that you can very easily scale up your entire application. So as a data scientist, you don't have to worry too much about whether you're dealing with converting your data from, let's say, a SQL data store to CSV, or you're trying to write a lot of boilerplate code for doing your machine learning inference, depending on what type of model you're using. So whether it's a PyTorch model, TensorFlow, scikit-learning, or Onyx model, and whether you have to think about, okay, like how should I, as a data scientist, deploy the model given that you might not have a lot of experience with doing that. So UnionML allows you to not worry too much about all of that overhead with respect to writing boilerplate code, and it provides you a set of defined methods that you can directly use and very easily build machine learning based microservices. And before that, before I go further, a huge shout out to Niels, who I think, I'm not sure if he's present over here, but he is the original creator of UnionML. So he's the original author, and of course there are a bunch of other maintainers as well, but a huge shout out to Niels, who basically inspired me to work towards this UnionML and really drive that this entire idea forward, that as data scientists you can very easily create machine learning based microservices as well. And of course, what I mentioned originally was that UnionML has been built on top of Flight. So I'll also just briefly discuss about what Flight is for those folks who might not be aware. So Flight is basically a Kubernetes native workflow automation platform that is data and machine learning aware. So whether you're dealing with data workflows or you're dealing with machine learning workflows, you can very easily just define your entire machine learning tasks in the form of tasks and workflows. So if you're aware of things like Airflow, originally Flight was something like that is built at Lyft, and it is built on top of Airflow. So now, of course, it has a lot of more capabilities as compared to Airflow. And you can very easily just define your entire set of machine learning activities with the help of these tasks and workflows. So the major goal of Flight is to be able to create this workflow automation system and provide this as a platform as service, so that you can very easily and reliably define your machine learning workloads and scale them up probably in a Kubernetes native environment. And you really provide segregation for both your data scientists and for MLOps engineers by the different set of tools that are provided within Flight, so that they can work independently and not have to worry too much about the tooling or the infrastructure that is required with Flight. And one of the core concepts within Flight is the concept of workflows and tasks. So tasks are the smallest set of tooling that, of course, could be you could have a task for just doing pre-processing of your data. There could be a task for the training of your data. There could be a task for doing the prediction and evaluation. And then workflows are essentially a combination, or you combine different set of tasks together, and you can run them as part of a workflow. So they typically use something called as directional cyclic DAS, so that's DAGs, which essentially are defining how these workflows run internally, right? And I'm sorry, I think oh, this one is still on? Okay, there might be something wrong with that one. So if you're able to see it, perfect. So essentially these workflows run as part of the directionally cyclic graphs, and they help you to define the order or the sequence in which your machine learning workflows are actually running. And then, of course, there are some other features that come out of the box with Flight, so including things like launch plans that help you to schedule and invoke these workflows. So there could be multiple workflows that you might have defined for your project. And then you also get declarative infrastructure. So on the go or on the run, you can define GPUs, CPUs, again required for the type of machine learning workflow you're running. And Flight is also language agnostic, so you get SDKs for Flight in Scala, Java, JavaScript, and Python. And so you can use it for any type of language that you want, and you can define these workflows in that language. And then, so the idea is that since UnionML has been built on top of Flight, you get access to a lot of different ML tools, and we'll talk about the ecosystem in a bit. But the idea is that whether you might have a data store of Snowflake or in SQL, or you might be using machine learning based models such as TensorFlow, PyTorch, or probably you might want to deploy your model to BentoML, S3 bucket, Lambdas, AWS Lambda, all of that comes out of the box supported with UnionML. And the idea is that by defining these different services, as I mentioned, these decorative functions, you can create individual microservices for your training, for batch prediction, online, offline prediction, and scale each one of these particular microservices on their own. So if you have, let's say, a requirement for a lot of having larger amount of compute power that is required for training, you could very easily define that just for your training function, so for your training microservice. And of course, if you're doing some kind of local batch prediction that might require less amount of resources, less amount of CPU bandwidth, you can very easily configure your UnionML app to be able to do so. And here's an example of a end-to-end UnionML app. So the example that has been described over here essentially is an MNIST dataset. It's a very popular dataset for different type of digits, and we are using a scikit-based logistic regression model. So we'll just go ahead and define each and every different step that you'll see inside of this particular UnionML app. So the first one is the dependencies. So we're just importing the dependencies. So one that you'll see is UnionML. So you can get started with UnionML by just doing pip install UnionML, and I'll be showing you a demonstration for that. So here we're just installing all of our dependencies. The next one that you see is basically we are defining the entire app. So over here there are two key aspects. So one is the dataset and the model. So the dataset is one of the core parts of the UnionML app. So think of the dataset as the specifications that are defined, and of course here as an example we are using the digits dataset. Of course right now we have not really imported our dataset, we are just defining the name of our dataset. And similarly we are also defining that what is our model. So in this we'll define what is the type of model that we are using. So in that case it's logistic regression. Now, the next one that we have is that we have a reader function. So this is basically part of our entire dataset module within UnionML. So here we are really just working with pandas.dataframe, and we are importing our actual dataset that's coming in from scikit-learn. But the idea is that, of course, this is an inbuilt dataset that comes with scikit-learn. But if you have your own dataset that might be existing in a CSV file, so you could directly just import that CSV file, use the pandas.read_cv CSV function, or if you might have a dataset that might be a SQL data store, so you could very easily write logic that can convert your SQL data store into a CSV file inside of the functions that are primarily meant for your dataset. And then we have other types of decorator functions. So the first one that you see over here is the trainer decorator function. So this particular function essentially takes your model object instance, and we are essentially training and fitting our dataset to the model that we are going to be using. So in this case, it's the logistic regression model. And then, of course, as the next step, once you have gone ahead and trained your model, you can use the predictor method to predict the model once it has been trained, and also then use the evaluator method, that's your decorator method, to evaluate whether the performance of your machine learning model is good enough or not. So what you see over here is that you're getting these ready-to-use decorator functions for reading your dataset, for training, for evaluation, for prediction. And as a data scientist, you don't have to worry too much about writing boilerplate code for what type of model you might be choosing, for what type of dataset you are using, right? Because normally if you were not to use, let's say, something like UnionML, you'll have to probably write 30, 40, 50 lines of boilerplate code each and every time you are importing a dataset, you are doing some kind of a pre-processing of data, or you're doing your model training. So by defining these decorator functions, that allows you to remove all of that boilerplate code and that layer of abstraction that might come alongside with it. And here's an example of like comparing between, so on the left hand side for you, yeah, it will be left hand side, it's like written an example of the same MNIST dataset written in scikit-learn, and then the rest one, of course, like the code might not be legible enough for you, but that example has been just translated into a TensorFlow based model, so with Keras. And thank God, we have the screen back up again. So it's, I think like the screen is happy with how the presentation is going on so far. All right. But yeah, I think like the biggest point so far, of course, so far we're just like, talking more about what UnionML is, how it works under the hood. But I think like this particular screen is probably the most powerful tool or the most powerful thing about UnionML, and how easy it is to really deploy your machine learning model with the help of UnionML. So you can choose whether you want to deploy your UnionML, your machine learning model as a web service with the help of something like Fast API. So there is a Fast API integration that comes out of the box, or you want to probably deploy your machine learning model as a serverless function with the help of AWS Lambda, or you want to probably scale up your machine learning model in a Kubernetes native environment so that it could be hosted and it could be scaled up and down depending on how much traffic you're getting with the help of Flight. So of course, as I mentioned, that Flight is a Kubernetes native tool, so you could very easily scale up your machine learning model with the help of Flight as a backend. And here is an example for like creating a prediction microservice with the help of Fast API. So the first code snippet that you see is basically binding a Fast API app with a UnionML model. The second screenshot that you see is basically starting up a prediction server with the help of UnionML Serve. So it's a CLI tool that is provided by UnionML when you do pip install UnionML, and you can very easily just start serving your Fast API application around and creating a wrapper around your machine learning model so that you could use it as a prediction service. And the third one is we're just using, like, you could probably create a client.py where you're importing requests and then running your prediction request that is running on your Fast API server. And I also just showcase this as a demonstration, so not to worry about that. And okay, and you could also deploy UnionML with the help of BentoML. So BentoML is a very nice tool for being able to do machine learning model prediction, and this actually came as one of the latest integrations for UnionML, and that also actually allows you to deploy your UnionML app to even more targets. So by default, UnionML has the capability to deploy with AWS Lambda, but you could also deploy your UnionML app with GCP, with Azure, by using BentoML. So documentation for which you'll find on the UnionML docs. I will share the link to the docs at the end. And you could also, of course, do more things with UnionML. So you can configure your UnionML app to probably request for GPU resources, allocate that on the go, on the run when you're defining your UnionML app. Or you could also define clusters. So if you're working with something like an Apache Kafka, or probably with, like, let's say with Spark, you can define these clusters directly inside of your UnionML app as well. Again, for documentation for this, you'll find on the website for UnionML. And so the idea is that with the help of this UnionML app that we have created, it's running on top of Flight. Of course, it's a very robust system, and you can create different set of microservices for training, for batch prediction, local prediction, right? And so yeah, I mean, UnionML really makes it easy for you to be able to create machine learning based microservices and then deploy them, right? And of course, this is a really important aspect of the entire MLOps architecture that traditionally we use. And again, the major goal, as I covered, is that it helps to unify all the different machine learning tools that exist today. We saw that as part of the entire landscape for machine learning, we saw that there are so many different services. So it's a very ambitious project, and it's still relatively new. So it just started off last year, and there are a lot of different integrations that are being built right now to make it even more accessible for probably for a different set of other tools that you might be using to make it very easy for you to be able to write machine learning based microservices, right? And here's an example of the end-to-end integrations that exist today or are also under development right now. So whether it's for deployment, so with like Fast API, Streamlit, or Fast, or whether you want to work with different type of data stores, different type of machine learning models, or if you want to, like, let's say, deploy them on serverless functions, all of them are inbuilt integrations, so you don't have to worry too much about writing boilerplate code for all these integrations. All of them come inbuilt with UnionML, and when you're writing your UnionML app, then you can very easily use them. And here's also like the roadmap. So of course, a lot of the production level, machine learning involves continuously monitoring your machine learning model. So you could probably use tools like Prometheus, Grafana, or of course you might want to explain your model, like, whether because model explainability is a very important aspect of ensuring that we are creating good and explainable AI, right? So you want to probably do things like model serving. So all of these are like part of the roadmap and might be released in the next like few months or in an year's time. And of course, now it's a demo. So of course, it's going to be a small demo, but I hope that this gives you a glimpse of the power of Union AI and UnionML. So let me go ahead and see if I'm able to bring up my VS Code. All right, so I'm just using a GitHub code space because there's some issue in actually installing the dependency for UnionML locally in my system. But just a quick 2 to 3 demos that I have prepared for all of you. So the first one is, and we'll just wait for the code space to start. All right, perfect. And I'll just bring up my terminal over here. So in order to get started, you just have to the first step that you'll do if you want to get started with UnionML is use pip install UnionML, and that would essentially give you the access to use the UnionML CLI. So in this case, 1 minute, let me just probably remove this code. Okay, so I'll just open up a new terminal, and if I zoom in a bit more, I hope everyone is able to see the screen. Perfect. So if I type UnionML, you can see that it works as a CLI tool, and probably it might be a bit delayed because the code space is just starting. So we'll just give it like 1 or 2 minutes at max to be able to run. All right, so you can see that UnionML is working fine. So in order to basically create a new UnionML app, you just have to use UnionML init. So it's to initialize the new ML app and just give a name to it. So we can give PyData live, and what it will do is that it will create a boilerplate code for you, and we'll see that on the left hand side. So over here it has created this PyData live, and here you'll find like a sample dataset with the app.py containing the entire code. So this is the same code that I showcased in the slides as well, which is for the logistic regression, and it's loading the load digits, and we can very simply just run this UnionML app with the help of Python app.py. So if we run this, you'll see, just 1 second. Okay, I'll have to go to that particular directory. So let me go to the PyData live and just run the Python app.py. So it will go ahead and give a prediction. And so you can see that it ran the logistic regression code. It basically gave you the prediction for both the training and for the test. And for like a random set of 5 data points, it gave you the prediction of the digits. So I mean 6, 9, these are all the digits. Similarly, I made one UnionML app myself before coming over here. So that one is actually for an iris dataset. And over here, so if you're aware of the iris dataset, it's a very popular dataset that has like 3 different type of flowers: setosa, versicolor. So I mean Virginica. And the model that I'm going to be using over here is a KNN model. So it's a k-neighbors classifier, again using the sklearn. And I'll go ahead and simply run this as well. So I'll just go back to my code repository, go to my iris dataset and run the Python app.py. And over here we are running the KNN classifier. In this case, what I did was, at the end of the code, I just ran a sample of 2 datasets. So over here, like what you see is basically the iris dataset. How it works is that it has 3 different classes. So you get, and basically the enums for them are 0, 1, 2. So you can see over here that we get a training score of 96% and test for 96, similar. And I can probably also increase the number of samples. So probably from 2 to 5 and run this again. And in fact, like this time I have taken 25. So you can run this and get a result for like 25 different samples. And the third demo that I just want to quickly show is for the fast API, right? So I can go to the fast API demo and run that as well. So in the fast API demo, the only thing that we're doing is that we are importing fast API and wrapping our entire fast API app for our UnionML machine learning model. And to run this, you just have to run this particular command, which is the UnionML serve. So I'll go ahead and run this. And this will open up like my service in localhost 8000, which will be live, and we can just go and see that in the browser. So that's basically a UnionML app. And of course, you could have something like a client .py, which can actually access to this particular fast API service and print the response. So in this case, you could just send a request for a load digits or any other model that you might be using for your prediction and use that. And since we are nearing on time, I'll just quickly also talk more about how to get started. So it's a simple 1-line command: pip install UnionML and UnionML init my app. If you want like a boilerplate code, so you can very easily get started with this. And if you like the project, you can give it a star by going into, so it's completely open source, by the way, to Union AI OSS and UnionML. And for the docs, you can read the docs over here. And of course, this is the QR code for the slides. So if you're interested, feel free to go through them and you can scan them. And my Twitter and my GitHub. And yeah, I'm open to questions now. Thank you so much.
Thank you for that. I was just wondering, does UnionML support more complicated training paradigms like distributed training or federated learning?
So I think I've not really seen use case for UnionML so far for federated learning, but given the fact that it has been built on top of Flight, so if you have such kind of use case where you are either streaming your data or you have, like, let's say, because in a case of federated learning, you'll have multiple edge devices where you might probably be breaking down your entire data and training them separately on each of these edge devices, right? Or what was the second example that you gave apart from federated
distributed training?
Yeah, so even for like distributed training, it's pretty much like this, right? That you have different, probably different GPUs and you want to train them sequentially, or you might want to train them parallelly on each of these particular devices, or you might want to also probably divide your entire data and then run inference on each of these GPUs parallelly. So that can be handled with Flight. So I've not really tested it personally with UnionML, but hopefully, I mean, that might be in the roadmap.
Gotcha. Thank you.
Any other questions?
I think there's this one.
Hi, thank you for the talk. Yesterday I attended the Flight talk, and Eduardo, when he was talking, he talked about how you can also deploy to, like, not just Kubernetes, but like through like AWS and GCP and all of that, and how Flight is kind of like, builds this abstraction layer for ML orchestration. And it seems like UnionML builds an abstraction on top of that. So I guess I'm still like a little confused on what's the benefit of using UnionML on top of Flight, like in terms of like I guess, why are we not doing just double the amount of work then?
Yeah, so I mean, that's a very valid question. So see, the major goal for UnionML, as I mentioned earlier, is so that as a data scientist, as I mentioned, right, that you generally have to write a lot of boilerplate code, whether it's for defining your model itself or probably doing a data abstraction layer where you're translating your data from probably, let's say, like SQL data store to a CSV file, because typically like pandas, NumPy, they work with the CSV data file, right? So the major goal for UnionML is to go away with that layer of abstraction and bring in integrations for such a huge amount of different ML tools that exist today. So deployment is, of course, one aspect of UnionML, but there are all these other different tasks as well that UnionML can actually accomplish, right? So it's not just related to the deployment as well. But generally, if you also speak about like Flight, right? So Flight, of course, works pretty well when it comes to deployment on GCP, Azure, AWS, because you can define like your Flight instance and you can host it on an EKS cluster, a GCP cluster, right? So that's the deployment side of Flight only. But UnionML also helps you to deploy your machine learning models not just on Flight or on Flight native workloads. It can deploy it on as a web service. It can deploy it as a serverless function. So I hope that probably gives you a bit more clarity why there is a need. So Flight, of course, is just an answer for answering like Kubernetes native deployments. But we have all different set of deployments that might not require a Kubernetes native deployment.
Thank you.
Hi. Just curious, this might be either a Flight question or a Union question. So if you're, for example, using Kubeflow in your current environment, can UnionFlow, and because Kubeflow runs on Kubernetes, and as you said, Union can work on Kubernetes, does that mean that Union can work also on Kubeflow?
That's an interesting question. So that's something that I've not really worked on myself. So I think like as far as the integrations, as far as I know, that there are no direct compatibility as of now, but probably the Union team it's also over here. So I'm not really aware of whether it can work on Kubeflow, but I know that there are some Kubeflow operators that are there for Flight. So that might be a use case that could possibly help.
Okay, and I got one more question is, can Flight, or probably UnionFlow, can do everything that Kubeflow does? So can it actually replace Kubeflow?
Yeah, I mean, there is actually a blog on the Union site that basically compares between Flight and Kubeflow. And I think, let me actually go to that particular blog if we have time. So it's Flight versus Kubeflow. So I'll probably, you could refer to this particular blog that goes really in depth regarding, actually when I was working with Union, I was involved in just reviewing some of this. So, but yeah, feel free to go through this particular blog to learn. And generally speaking, Flight is being introduced in such a way that there are some better features for Flight as compared to even Kubeflow, especially when it comes to dealing with notebooks and dealing with the Union Flight tasks and the workflows that are built, right? They're analogous to the different pipelines that we have within Kubeflow. So there are some improvements that come with Flight over Kubeflow as well.
Okay, thank you. So if there are further questions, feel free to reach out to Shivay directly. And thank you very much for this talk.
Thank you.